All of these types that we use to declare a variable, and more, there's more, um, all of them are called primitive types. These types came along with C#, and we use them to declare variables. Let's understand something about these primitive types. First line, we declare a variable called int number 1, and we set it a value of 10. In the second line, we declare a variable int number 2, and we set it to the value of int number 1. So now they both are equals 10. But the question is, are these both variables share the same 10 value, or each one of them has its own 10 value? So the answer is, they are not sharing the same 10 value. Each one of them has its own 10 value. Because in this line, when we set int number 2 to be like int number 1, it means that the value of int number 1 is copied and set to int number 2. Not the same 10 value, but another 10 value copied and set to int number 2. Means that these two variables do not share the same 10 value, but each one of them has its own 10 value. And because of that, if we will change the value inside int number 2 to be 20, it will not affect the int number 1. It will stay 10. Because they are different. And even if we will send the int number 1 to a method called change my value, we'll send this variable, int number 1, to this method. And inside this method, we will change the value of int number 1. Let's see. Change my value. We send int number 1 to this method, and inside the method, in the body of the method, we change the value of int number 1 to be 1000. It will not affect the int number 1 up there in the main method. This int number 1 will not be changed, it will stay 10. Because when we send the int number 1 to this method, we actually do not send the int number 1 itself. We just copy the value of int number 1, 10, and we send a copy of the value to this method. And the copied value is copied into this int number 1. It's not the same variable that up there in the main method. This int number 1 is a local variable inside this method. And it has the value of 10 because the value of the real int number 1 up there in the main method is copied and sent to this method. And now inside this method we change the value from 10 to 1000, but this did not affect the int number 1 up there in the main method. It's still 10. If we will print it, we'll see that int number 1 equals 10, int number 2 equals 20. The same thing is with double. Double number 1 equals 5.5. Double number 2, we set it to double number 1. So the same thing is here. They are not share the same 5.5, but the 5.5 here is copied, and we set it to the double number 2. So because of that, if we will change the double number 2 to 5.6, it will not affect the double number 1. It will stay 5.5 because they are not the same. Each one of them has its own value. If we will send double number 1 to this method, also same thing. We are not sending the real double number 1. We are sending a copy of the real number 1. We are sending a copy of 5.5 to this method. And inside this method, this is a local double number 1. even though it's the same name, but it's not the same variable. It's a local double number 1 for this method. Of course, the 5.5 copied here to this variable, and inside the body of the method, we change the local variable double number 1 to be 1000. But the double number 1 up there in the main method, it hasn't been affected. It's still 5.5. If we will print it, we'll see that double number 1 is 5.5 and double number 2 is 5.6. Same thing is with decimal, and the same thing is with string. What all of these type have in common? All of these are primitive types that came along with C#. But they have one more thing in common. All of these, actually string is not, all of these are, when we declare a variable, for example, int number 1 equals 10, the value is stored somewhere in the memory, and the memory called stack. All of these, int, long, byte, bool, double, float, decimal, and more, the value stored in memory called stack. And even though string is not like that, string is stored in other memory called heap, but for some reason it behaves like all of them, that all of the other primitive types that stored in stack. And the behavior is that when we set a variable to another, or we send a variable to a method, we do not send the variable itself, but a copy of the variable. This is in common for all types, primitive types that stored in stack when we declare a variable. And even string that is stored in heap memory is behaved like them. It's also a primitive variable that comes with the C# language, and it behaves like all other primitive types.